And welcome to hypothesis tests about the mean difference. So, the idea here is sometimes we get um, essentially paired data, for example, before and after data, where we're not concerned about the individual data values, we're concerned about the change in data value for each individual. So, sometimes we have paired data such as before and after data from each individual, where we are not concerned about the two values separately, but instead care about the change. Um, so, for example, um, we might want to know how some uh, diet changes weight. So, we might wish to know how effective a certain diet is on weight loss or in terms of weight loss. Right? And so, presumably for each individual, we would have their before weight and after weight. So, we might have um, person one had before weighed 142 pounds, and after the diet is over, weighed 135 pounds. And then we might have person two weighed 193 pounds, and after weighed 162 pounds. And person three maybe weighed 165 pounds, and after weighed 163 pounds, right? And then keep going for all the people. So we're not so concerned about the average before weight and the average after weight. Instead, we just want to look at what is the average weight loss. So what we're going to do next is find the difference. And we typically do after minus before, sometimes even do before minus after. Just make sure you pay attention to which one you used. So if we do after minus before, then we have 135 minus 142, otherwise known as -7. So we dropped 7 pounds. 162 minus 193, we are looking at -31. 163 minus 165, we are looking at -2. So instead of studying these individual data values, what we will do is we will simply study the difference. So we will study the differences or the changes. And so instead of having two lists of data, we've now just boiled it down to one list of data. So we are now just working with one list of data. And so what we can do is we can simply run a hypothesis test on this one list of data. And we will use the t-distribution. So we're going to run a one mean test using the t-distribution on the list of differences. So we would need to use some calculator to find the sample mean and sample standard deviation of that list. We would need to know our sample size, and then we can just run with a hypothesis test as we usually would. The way we write our hypotheses we can use the word lowers or increases. So our alternative hypothesis in this particular problem would be, on average, the diet results in weight loss. And then on average, there is no change in weight. From the diet. So our null hypothesis here is that the mean difference, so I'm going to write mu sub d for the average distance or difference, is equal to 0. There's no change, there's not a positive gain or a negative loss or a loss, right? Versus our alternative hypothesis would be that the average difference is less than 0. So less than 0 implies that there's a drop or a loss. If it were greater than 0, it implies that there's a gain. So again, at this point, we're just working with a null hypothesis of the mean is equal to 0, an alternative hypothesis of the mean is less than 0. If you have used a calculator to find your mean sample standard deviation and you know your sample size, we can now just run a regular one population hypothesis test using the t-distribution. So that's it.